What's up, everyone? How's it going? Let me just, I see. I had to go into presentation because if I wanted to pull up all of the past pictures from from my iPad and my iPhone, this was really the only way I could do it. But I ain't a goat. I ain't a goat. But I do want to adjust these a little bit. So as people filter in here, I'll just adjust a few of these. So basically, if you're curious how this is gonna go, I'm gonna go over like all the stuff that I would break down if this were just a regular winter storm, basically. Um, I go over 500, the 700 stuff, different aspects, radar, how it developed and how it relates to the upper level and mid level stuff. To me, we're not. You notice if you look through these slides, there's not a single P-type map on here. I was looking for a P-type to connect it because I get it. It's easier to connect the P-type map, the precipitation type map to the upper level pattern and stuff. It's easier to see it that way visually, but I didn't even have one saved. That just lets you know how much I use it. Actually, no, we can leave this down here. All right. Let's do it. Do have a couple of Billy's old tweets too that we're gonna use as well, and eventually probably some of the YouTube folks will come in as they want to. So let's do it. Let's do it. So this was, actually, I can even bring up. I got one more thing I need to bring up. One more thing. Yep. And this right here. This was actually National Weather Service in March later that year did a really good breakdown. So we'll be able to use some of this stuff too. But let's start off. Let's go directly into the snowfall totals. Let's go through this. That's kind of how I want to start. I'll zoom in. That didn't work as well I want to, but you can still probably see pretty well. So right off the bat, this was the pen tool. And there we go. Now we're cooking. Let's cook. Ooh. Yep. Let's cook. So right off the bat, you can see, if we start from the end and then go into the beginning to explain how it happened, I think that's a good way of doing this. Rather than just like throwing a bunch of things, because if you don't have reference of what the snowstorm was, it just feels like I'm breaking down a new setup, which I kind of want to do, but I want to break down the setup so you have a little bit of context of what happened, and also at the same time you can feel like it's a new storm. So that's kind of what I'm kind of going for. But right off the bat, things that are sparking my mind here. This right here, I even circled that. This was your jackpot, pretty clear. Hudson Valley, down into eastern PA, northern New Jersey. That was your jackpot. And then we also had an interior band set up. And then we also had some good stuff in coastal enhancement in here and also up here. So those are the things that kind of immediately, when I look at a snow map like this, those are the things that stand out. This was your jackpot. This was your your 20 to 40 inch range. This was more 20 to 30, but there were some 36 inch totals. There were some 3 foot plus totals in here. And then this was more of a 12 to 24 range. I think there was 1 2 foot report that didn't make it into the official NWS PNS, but they did. The PNS is their final report, basically, or not final, but they do PNS statements, throughout the storm, and then their final one, the NWS does for the official records that they have. And so this was a nice 12 to 24 pocket. I'm living here, so I know about this one. And then this was associated. We'll talk about it more, but this was a pretty broad 500 millibar trough, and so, but there were multiple injections of energy to the trough, and that's kind of why that allowed some good dynamics to continue to be pumped in, to get backed. Remember we talked about back in the flow and get pumped in. And we had this interior band set up that kind of shot down stuff by the end of the storm like this. So we backed to the flow to the point where it almost did that full circle kind of. So you got a pretty good idea. So we have that, we had an initial piece of energy, and we had a transfer, and you can kind of see that with the snowfall totals this way, and then not quite, it's kind of a secondary low, I guess you could say, and then that's not where quite the low pressure is. It was relatively close. It was more down here, but as that transfer took place, you can see screw zone a little bit. But DC and Northern Maryland ended up doing out in the Delmarva even a little bit, not down here, but northern parts of the Delmarva ended up working out pretty good, because remember we were talking about the end of the storm. That wasn't quite back end snow. It was just more injections of vorticity into the trough, and these kind of slid their way all the way down. So they get a little front end thump. They did, and then they mixed for most of the storm. DC did. And then from at the end of the storm, that's probably where they got their most snow, DC, in this one, is because they were able to pick up on that ending stuff towards the end of the storm. And then here, Maine picked up on a lot of, at this point, the surface low wasn't really intensifying, but just how, like we talked about here, with the, just like we talked about with this interior band and how it was being aided by injection into the trough. Same here. Maine still really, as the surface low moved, Maine was still pretty close to the surface low, and also still had some pretty decent dynamics that were working their way. You can see here, still some pretty good dynamics. And with the injection of energy swinging around the trough, which will be much more visible in a second, you were still able to back the flow some off the surface low, and also off your 700 energy, and your 500 millibar was still injecting that energy, and you had still some decent juice left in the 700 in the mid levels, and that's why Maine was, northern Maine, you see these totals out here. Maine was able to make out pretty good north, a wide spread, and 8 to 16 plus inches. Even though the surface low wasn't strengthening anymore and it was kind of decaying, because it peaked in this range, they were still able to make out pretty well. And now that brings me back here. So I'm going to see if I zoom in or if I click slideshow. Will that? Yeah. Okay. So now you can see it much better. But now I can't draw on it, and that's a problem. Escape. So let's see if I just zoom in. No, it doesn't. Actually, we zoom out, it gets bigger. Ironic. Okay. So we'll do that. Honestly, I can just click from side to slide a lot easier now. So that works out pretty well. So this was this at this point. This is our 500 millibar setup. This was I tried to get as many as I could pre, but I wanted to get more. But this will explain it pretty well. And actually, it's a good segue from what I was just talking about. So you can see if you look at this, it doesn't look like it's like a crazy. If you know 500 millibar, this doesn't look like a crazy 500 millibar setup by any means. We have when it relates to the other mid-level dynamics. That's where you start to connect the pieces with this one. But just generally speaking, it's not a crazy 500 millibar look setup. Now, with that being said, this is a really deep trough. Look how deep this thing's going. I mean, we're digging this trough base all the way down into Florida. I mean, this is a really deep trough base. The problem is, notice how this trough doesn't completely round all the way, and it kind of gets cut off here, and all of this is a little bit disorganized. But this is where the magic's happening, obviously. But this is where it's a little bit disorganized. It's not. There's a lot going on here. However, what we see with this is we're going to get this initial. We look for the trough. I can even go back to here. This is 500. Let's surface. We want. Is this 5? Yeah, here's 500. Okay. And remember, we talked about when we look for intensifying. When we look for these intensifying systems, you notice. I go back to here. Notice that this is at this point we're still not quite negative yet with the trough. It looks like still slightly positive. Still slightly positive, and crap. See, I'm used to the current time, so the winter. This is around 1 a.m. I believe. I think so. So at this point, the trough is positive, just barely. It's almost neutral. You can see it's like this. It's hard to see the contours, but it's almost neutral. About to turn neutral, and that this was about the time I went to bed. I went to bed while it went neutral, and then I woke up as the trough went negative. And honestly, at this point, no, it's more. I'm trying to figure it out. Yeah, it's still slightly positive, even though the trough base looks like it's going like this. The contour lines say a little bit differently, but it's basically almost neutral at this point. But notice we have all these pieces of energy here. Notice we have a big ridge right here, and with this ridge, boom, it's coming down and working like this. So this is our flow, just about. So this kind of flow is really what we look for at the jet stream. We have a big pumping ridge, into the Rockies and plains, and then Western Plains, and then at this point we start to see the dip in the jet stream, and this is a really deep digging trough. So typically, with the trough this disorganized, you don't get, well, you can. It's just, it depends on the setup. This was a pretty unique setup, where it's a pretty disorganized trough at surface look. Yeah, not literally the surface of the atmosphere, but just at a surface level view when you're looking at this. And the depth in the trough, you would think would be a little bit, the appearance would be a little bit more organized. But we have all these injections of energy that are come in, and they're going to help really organize this at 500 millibars. Still going to be a rather broad trough base, given the type of, given the dip in the jet stream, and the powerful way we're going to back the flow here. That's a little not too scientific to say that. But and if you're not sure what backing the flow is, it's this energy that comes in here, and once the trough turns negative, once we look for the trough to turn negative, that's where, this, the trough starting to turn negative. This is injecting these pieces of energy are injecting into the trough, and they swing around the trough base. And then the moisture that gets pulled in from here starts to pull in here. And as we turn negative, then the flow of the moisture gets turned this way. And that's what we call back in the flow. I don't think I'm doing that bad of a job, but it seems like either a lot of people aren't that interested, I guess. But I guess it's not as interesting as I thought it was. But I mean, a lot of people seem to like it today on Twitter, so I thought we would get a decent showing. But notice here, right? We're getting all this. We talk about this moisture at this point. Notice how the pumping. Right, this is the overrun. This is a little bit from the upper level low out here. So this is, moving like this. So moisture is pumping around the trough base. It's pumping around. It's coming around the trough base, but it's still not, since the trough isn't negative yet, we haven't backed the flow yet. So at this point, trough is still positive. So moisture is running around the trough. It's still not quite able to back in yet, but we do still have, we talk about this is a little bit of a transfer going on here. So at this point, we still have the initial moisture made out pretty well. This area did. I think they came out, the Chicago area pulled out, this northeastern Illinois. I think they came out with a pretty good sizable snowstorm with this one as well, just from the original upper level low. And then, so it was still positive, but then as we start to get negative, notice how the moisture, this was the best picture I could do because I kind of drew on it already. But notice, this is later in the storm at this point. So as towards the end of the storm, we're still backing in moisture at this point. This is an in-between picture. I would have liked to have more because it would have demonstrated this moisture would be a little bit farther south and it'd be backing this way because that's how it originally happened. And notice this is later in the storm, so it's now starting to turn more counterclockwise because it was a bit later in the storm in the evolution where we saw with this trough. With this trough, we saw more of this vorticity getting injected, swinging around the trough base, and at that point, we're starting to get, the flow wrapped around the system, and that's where we saw those bands that just trotted down, that looked like bands trotting from the north to south, which is why we got that, and I can, show you here on radar. Yep. So this is around where it's starting to go neutral. Notice this moisture here is still moving in this direction here at this point, but notice some of this moisture down here. It's a little bit more due north than rather northeast. All right. Notice this moisture pumping out just to the east. You notice how it's not quite able to back in yet, like we're going to see eventually. And if we play one more loop, this is when I woke up. Notice now, once the flow starts to back, you see now how this is getting pushed. Even then, we haven't completely backed the flow. We're just starting to back the flow. But this is when the mid-level dynamics were starting to get really good. I'm starting to get a little ahead of myself, but I just want to demonstrate the difference between when your trough is still positive and when it starts to go negative. And that's when your trough goes negative, that's when you can start to wrap the moisture around the trough and push the flow of the moisture this way rather than this way like we saw in that last radar GIF. And again, we showed you I showed you the 500 setup. No one else did. Um, I showed you the 500 setup, but also we had really good 700 setup. So this is about, it's pretty close to the same time. It's a couple hours off from the radar loop I just showed you. But look how good our 700 volt is what you look for on models for banding. This is really where you start to look for banding, the good mid-level dynamics. And what we're looking for is we're looking for really good mid-level dynamics, and we're looking for a storm with a lot of moisture that can get pumped over those really good dynamics. And when we can get that combination, that's when we can start to see that really intense snowfall banding. And you can see here, this is a pretty solid band right here. This is a pretty solid band that models are picking up on at this point. Obviously it developed. You can see, also notice this energy's offshore. It gets pumped in. And that's this is all, energy from our system that's getting pumped in. And this main band is was the big show, obviously. And then gradually it shifted a bit northwest, started to pivot. Bands that pivot means we got a trough that's gone negative. And that is what we want for. You can see here on 700 millibars too, a bit later. This is a few hours later. Just intense 700 millibar FGen. And, this is Phrenologenesis. We look for these FGen bands to set up. And this is what a lot of times in these storms we look for. We look for where that intense Phrenologenesis banding is going to set up. And from this point on, that's when we can start to put, once we get close to the storm, we can start to put the pieces together with where the mid-level dynamics are showing those heavy snow bands. And then from there, it's a little bit of a guessing game. You got to pinpoint stuff at that point. Which is, when you see this at 700, this is, you don't really look for right here. You look for on the north side and just to the west. So this whole area, you look for right here is where you're looking at. And at this point in the model showing it was a little bit, it was pretty close to this, but it wasn't quite exactly like this. But it was pretty close to that. All right, this is the same. This is a little bit, this actually is almost an hour off to show with the radar I just showed you there. That this is, notice all this cyclonic vorticity. I keep calling it energy, but really the term is cyclonic vorticity. It's getting wrapped around the trough base. Remember we talked about this trough base here. And this is a little later on in the system, so it's hard for me to demonstrate because at this point, that band that I'm showing you is over here. But this energy is getting wrapped around the trough base. Boom, here, and the moisture fetch we're pumping in is what really allowed, to get over those mid-level dynamics, is where we saw this thing really take off. That combination right there. And I'm just, all right, we got you two folks in here. That's good. Yeah, no, this is a reanalysis. It says reanalysis. This is just a reanalysis. This is just a reanalysis stream. So it's not, I'm just going over a past winter storm. I pitched it out on Twitter. It seemed like a lot of people were interested. I guess I was wrong. Or I guess I should have picked a different day. So a lot of people seemed interested, but they haven't really, maybe it's my fault. It's the timing of when I do these. I'm busy a lot during the early evening hours, so a lot of people, maybe that's when they envisioned me doing that, but I mean, I've been pretty consistent with the timing that I've been doing these streams, so maybe they'll watch it at another point. But it started out okay, but I mean, at this point, 0 to 2 people in the Twitter is not exactly what not exactly how I thought this was gonna go. But I started it, so I'm gonna keep going and do it as if there were a lot more people. Because for the people that are in here, I owe it to them. Thank you for whoever's in here right now. What was it? What was that match? Oh, here we go. Yeah, the moisture. Notice that, and also one thing I should mention is notice, a lot of time we looked at this with the December 2020 snowstorm, which I guess I kind of did that over Twitter, but we could do that in another stream, I guess, as well. But what we look for in these CDC surface temperatures is typically a bit more tropical. When we look at these sea surface temperature maps, but notice there's some cool patches, but notice particularly there's a lot of really warm sea surface temperatures all up in here. And thank God I didn't finish drawing that. That could have been disaster. But remember, we have this big trough. We have this big trough. That's a little more positive. But when we get this, when it starts to go negative, now when it goes negative, we get it here. Now we're pulling all this Caribbean moisture in these really warm sea surface temperatures. Just off here, all these warm sea surface temperatures, that goes into it as well. Now the flow is being backed, and now we're pushing moisture with above average sea surface temperatures into the system. So warmer sea surface temperatures, we can pump in a little bit, slightly more intense moisture, and every little bit more you can pump in over those really strong mid-level dynamics like this, that's what we look for. These really strong mid-level dynamics. You can see here, this will kind of match it up in a second. This is right the strong, so you look for just on the northern fringe of it, and then you look just north of where it is, of where you can see the cyclonic vorticity at 700. You look just to the north or just on the northern part of where those deepest shades of red and black are, and that's where you can match it up on radar. And I think I'll be able to match it up pretty good. This was a little bit later in the day, but yeah. See here, this big band, it's kind of starting to split at this point, but this was what was pumping moisture, and this is what allowed us to get these big snowfall totals, especially in this area, who was waiting for a massive snowstorm for a while. But then also eventually this band, really where you get the biggest totals, where this band pivots. So they got, boom, those snowfall rates, and it was just felt like it was there continually sitting in Nile, even though that wasn't pivoting over this New York City area. It was sitting over them for a while, and then once this band started, this is where make a little bit more sense. And then once this band started to get going a little bit farther away, then we saw this band start to pivot over this area. But even at that point, we're still getting this band that's still associated a little bit with the really good mid-level dynamics that are pumping off the 700 low and off the surface low that's strengthening. So this is a lot of still really solid mid-level dynamics at this point, but also the surface low strengthening. You kind of see this moisture still pumping in here, and still getting good banding over southwestern Connecticut and southern Hudson Valley. even though this is the main band. This is the main band right here. Remember we talked about 500, so this was what we look for. We had this big, closed off upper level low still, right? Because we talked about this was still producing some pretty big snowfall in here. So they had this upper level low roll through, and then it kind of moved over to the east. And then we talked about this on the last stream actually with this intensifying snowstorm we got right now, or not snowstorm, but this kind of low pressure system right off the coast, this upper level low that kind of produced some significant, not significant, but more than usual coastal flooding today along Jersey and Delmarva. But as long as you have some 500 energy to work with around a trough, all it takes is you to inject some energy into that. And that wasn't the greatest color to use. All it takes is for you to inject some energy into that trough, and that's what we did. And from that point on, we kind of strengthened, reignited this 500 millibar setup. In this case, reignited, but this became the main show rather than this snowfall. So reigniting to the point where this was going to become even more significant, this East Coast snowstorm, even more significant than what we saw out here in the Midwest. And you can even get an idea of what some of these snowfall totals they were projecting here in this National Weather Service in New York City or Upton, I guess you could say, because technically it's like on Long Island, just east of New York City. The snowfall totals that they were advertising were off the charts, and this is their thoughts for here too. MWS Boston didn't really go. They tend not to go all in right away as well. They tend to be a little conservative in the beginning until they feel they can upgrade it, and then once before the storm happens, you're really getting if they're all in, then you'll be able to see it. But this is this is they did a decent job with this too. Maybe a little too far with these didn't want to go that far. Maybe a little bit too far with some of these 18 to 24s that went, but this is they had a decent idea. I even went farther than this with the 16 to 24. I think I did something like that. But this was here big. They were advertising. They saw the potential too. 18 to 24 plus and they kind of nailed this 24 to 30 area. It was I think it was all in here or whatever. This was their 24 to 30 area. But this was, I think they were off. I think they might have pulled this a little bit too far south, possibly as well, because I don't think Philly got 18 to 24. I think matter of fact, I know Philly didn't get 18. I think 18 to 24. I think they got a foot, but still, the National Weather Service in Upton, they were bought in on this, and for good reason. This was a widespread, 16 to 24 inches all around the New York City area. Central Park, which always reports 2-3 inches below everybody else, that's normal, I guess. For they reported still 17 inches of snow, I think. So that was New York City's biggest storm in years, probably since Jonas, honestly. Yeah, I know it's not most professional call them by names, but a lot of people just remember the names. Is this the one? Here we go. Wonder if I can. No, this was one of Billy's tweets. Very good follow, but he knew, even he corrected him. So this wasn't quite back end snow. It was just energy, the swinging around the trough and getting pulled in. So this is 700 millibars right here. These are the mid levels, and what allowed the system. Why we saw these snowfall totals that were so big was a big part, and the reason was is we saw prolonged snowfall for a couple days, really. I mean, almost 3 days for some areas. It was a ridiculously long event, and part of it was it was a disorganized trough, but it was still a pretty broad trough and also a very deep trough. So what that means, it's going to take a little while for that thing to get out of here, especially if it's not moving particularly fast. And it really was an interesting storm. From a meteorological perspective, there's so many flaws with this system that were kind of worked out for many people, and also technically didn't work out because for some, especially a lot of my friends out here by the coastline, a lot of my Twitter friends did not make out so well. I mean here because without with this surface front moved a little, the coastal front just sat about 5 miles inland and shunned Boston, southeastern Mass from really getting into some significant totals. A little bit, part of that, there's coastal fronts you're always looking for around Boston with these kind of storms, especially when the flow gets backed in. But without consistently heavy banding, um, and without with such a disorganized 500 millibar setup, 700 millibar, it can be a little bit. I mean, 700 wasn't all that disorganized, I should say, but 500 millibar was, and without as much dynamic cooling to be able to cool the column under the heavy banding, it was really hard to see any significant banding, because even when the good dynamics were here, they were so close to this coastal front that they kind of got cut off because those wet bulb temperatures, the snow was just too wet to be able to accumulate. There were some of those surface temperatures, not just surface temperatures, but some of those temperatures in the mid levels and down to the surface were just a little bit too warm, and we saw wet snow for them until they mixed and went to rain, and then they got screwed, which sucked for them. But just to the west, that kind of helped a little bit of big time banding and still pretty good temperatures as well to work with, which I can go into a little bit how I was affected more later, but still just going over some just general view. And this was, it's a little fast here, but you can kind of see what you can notice at the end of this loop, the way we'll go blue again. Notice at the end of this loop, the way they kind of get reinvigorated almost, you can kind of see, and then how it starts to pivot around. Notice these mid-level dynamics, how they get reignited. That's more energy swinging around the trough base, like we've mentioned a few times already on the stream. And let me get here. That's more energy being injected around this and this kind of connects to the other tweet. Is more, he's highlighting more pieces of energy swinging around this trough base here, working its way into the system, and that's why you can see there's really, really good banding. A little bit banding here for parts of New Hampshire and Maine, and then also this big interior band, which will be visible on radar when I pull that up. And that's why, as this band pivoted around, we saw still really good mid-level dynamics working with this system. And this was just really all still pulling in moisture around this trough into the mid-level dynamics, still pulling in a little bit of moisture. But this was a big mid-level dynamic show at this point, pulling these snowfall down. And that's why it was so prolonged for days after. I mean, not days and days and days, but 1 to 2 days. Once the main event got done and through, the second half of the event was still pretty impressive, because this is what turned people that saw 18 to 24 inches just off the gate. Because really, New York City, they kind of mixed a little bit after. They were too close to notice the upper level low here. This is a double closed off low. So a rule that Bernie uses is every closed contoured low. He got it from a friend of his or someone he knows. Remember, but every one contour closed off is you look for that many feet of snow. It doesn't apply to every system because there's nuances in every system, but that kind of applied right here. I guess you could have added a third one. So that's kind of a nuance right there. Because this was a 2 foot plus system. But it's just such a broad upper level low, you can see here. Still a pretty broad trough. And this is what turned with these pieces of energy shooting down and around their trough base. This is what allowed places to go from 16 to 24 inches, 16 to 20 inches, into those 20 to 30 to 3 feet totals and across PA. Notice here, and I guess I could pull it up quickly. Pull up the snowfall totals. Notice that interior banding here. So that main interior band. So they didn't really get in too much onto the main show originally, but they worked in the second half of the event out here in central New York. They worked their way into this interior band that set up. It was originally part of the main show, I guess you could say. All right, I'll see you, John. It was originally part of the main show. Thanks for popping in, my man. What was originally part of the main show with this, is eventually with these mid-level dynamics kind of ramping up with more energy wrapping around the trough base. From here, this is where we're seeing more this big band out here. But we're still getting more bands that are working their way south like this. And this will make sense when I show you here. All right, so this is our interior band that we just talked about. This is where they picked up, 15 to 25 inches. Maybe, I don't know, maybe not that much, but, the good 14 to 24, maybe something like that. And then notice also feeding into that, but also pulling south are these bands here working their way down. And it's still not fully, so it's more like this. And then eventually it'll pull in like this. So it's kind of getting pulled in more like that. So we're pulling these bands down from the north with these strong mid-level dynamics. And that's how they got into a lot of these bands that were still producing pretty heavy snowfall rates because they were cold temperatures. There was a really good cold. I should have talked about that in the beginning. But we had cold air working. We didn't have a big time high pressure, I think. I shouldn't. No crazy high pressure. But with such a deep trough base pulling down, some polar Arctic air. That's how you're able to create and manufacture a lot of cold air in the system. So the backside of this trough has really got a lot of cold air. This is cold air diving down. And then warm air meets cold air, and that's where we can create big time, frontogenesis and bandings. And a lot of stuff in meteorology is warm air meeting cold air is where you get a lot of that interesting stuff to happen. Probably hurricanes. Hurricanes aren't really hurricanes in terms of genesis and what they need are a little bit of an exception at the surface level. But technically, there's just hurricanes are just rotating thunderstorms, and thunderstorms create big cool cloud tops that we all the time we notice, and create convection, and create convection. It's warm air meeting cold air. So really, warm air meeting cold air is what we look for so often, so often with a lot of these storms. Yeah, John is always he loves the content. So if you know it's not really hard to come in to something that he enjoys, and I guess he enjoys the content. So I'm glad when you have people that consistently show up for you. That's stuff you can't take for granted. But this was a really unique setup. This was a unique setup. There's basic things you look for in every setup. Like, again, we look for this big deep trough. We look for something that's going to get injected into it. In this case here, it's a little bit different, but we do have vorticity being injected. We look for a lot of moisture that can get pulled into the system, and when you get a trough this deep, you have a really good moisture feed to pull into. You look for a good moisture that you can pull into. In terms of duration, a lot of the size of the trough, how broad it is, how much it tightens up, how much does it intensify. That can tell a lot of times the duration of a storm when you're looking at this. So with a trough that big, you're going to get a pretty decently long duration event. Just in general, even for some places that might be a little bit different, because might go from snow to mix, and it doesn't feel like, excuse me, that you're in the snow for that long. But also, some places then can, if you work too close to either the 700 or the 500 low, then that's when you start to worry about some subsidence or dry air. And if it moves too close, then you feel like you kind of get cut off, and the storm ends quicker or it pauses for a little bit longer. And that's what happened with me, because I didn't, I got into the initial, it lasted for a pretty good amount, but until this got too close, until our 500 and 700 low got too close to me, um, this where all these people made out the interior, and I didn't really get to work into any bands after that. But I still made out pretty well. I got like over 20 inches. I think this was my first 20-inch snowstorm in years. Closest thing I had before that was March 2018, I think. And before that, 2015. Yeah, 2015. Nothing will beat 2015. Hopefully this year, but no, I don't see anything beating 2015 for a little while. That was historic. I mean, when I'm doing this stuff too, guys, if you have questions about certain meteorological stuff I'm talking about, and maybe it doesn't quite make sense, I'll try to, because there's only a couple people here on Twitter, that are still on the stream. So if you have questions about some of the meteorological stuff, and how it works, maybe to help better understand it, because a lot of times, I know I had a lot of people come in for that were more for Hurricane Ian, and so a lot of you may not live relatively close to a lot of the mid-Atlantic and northeast snowstorms that we'll be going over, or just East Coast snowstorms in general. But hopefully we'll have a lot of streams to be doing in the wintertime. So when I go over this stuff and you want to come into the streams, I just want to make sure it makes sense for you guys that are curious about it. So this whole time I've been talking about when we go from positive to neutral, which I kind of talked about already. I went over this, but this radar clip is a really good way to represent that. This was, remember, we showed you the trough base when it was almost neutral right here. I think it's about that time. Yeah, this is about the same time with the radar. Still positive by the slightest hinge, but I mean, it's just about neutral, almost neutral. And this is how we kind of can connect it on radar. So notice the flow of the moisture. It's moving this way. And then now notice moisture is getting pumped this way. That represents, that's a pretty visible difference. Once we start to back the flow of the moisture, now that's a pretty visible difference that our trough has gone negative. You notice here in the beginning too, remember that in general, these things, this is 700, but in general, these are just, it's an intensifying storm. So just like it's a cyclone, it's a mid-latitude cyclone. So what we're looking for, just like a hurricane spins, in the broad scheme of these things, it's going to be a bit bigger and a bit wider, but this is going to spin just like you would see a hurricane. It's just a bit broader. It's, I mean, if you can kind of connect, we talk about those baroclinic processes. They make in tropical cyclones, they tend to expand the wind field. So imagine this is a baroclinic, so it's the baroclinic process. There's no need for that to happen, but at this point, where this is a significant, it's already a pretty significant big mid latitude cyclone. I mean, it's fumbling my words for a second there, but you can see the spin, and as once the trough starts to get negative, then we start to spin around, and you can kind of see it, and that's where we get snow bands to pivot inside, because originally they set up shop here, the flow starts to back, and then the snow band has to pivot, and until it gets pulled out, until the storm movement starts moving far enough away, this will either rot or will kind of get pulled out and slowly weaken. So if I play through some of the radar clips, I mean, can I? Yeah, okay, this will be easier. All right, so this was around 10 to 11:30. That's that big band we were looking for. That's how New York City got so much big totals, because they were so close to the Atlantic and so close to this pumping moisture with these heavy snow bands that they got into a lot of those 2 to 4 inch per hour rates. So you progress, that band starts to get pushed farther inland. And then at this point, the flow is really being backed. Moisture is getting pushed this way. And now at this point, New York City is over. Notice how there's not a lot of precip. We have this radar. So the farther the radar site, it's going to be harder to pick up on more moisture. But even then, still picking up on some of the stuff out here. But notice it's not really picking up on a lot in New York City, or just even some faint radar echoes. Not even picking up on any of that because we're too close. We're too close to the low pressure system in the upper levels, in the mid levels of the atmosphere. Um, I would have to really go back and figure out if it was 500 or 700 or both of those possibly. Too close. So New York City probably mixing a little bit at this point, and there's no heavy precipitation going on. And this is eventually going to, move this way. And then, but you can see this pulling around here, and this is starting to set. So we're getting precip farther back into New York State. This is pushing out, and then eventually it's setting the stage for once this really starts to wrap up even more, we get more energy, right? Remember the trough base, more energy to shoot around into the trough, more vorticity. It's the proper way to say that. Then that's when we start to see this band pivot. So that's why when we saw those big totals in upstate New York from that big band, that's how we saw that. But notice here, we're kind of, this is, you can see close to where I live. Notice this is, right, we're back in the flow. This is getting pulled in, but we also got some pretty good coastal enhancement from the surface low, and still some pretty decent mid-level dynamics at this point, even maybe not quite as good as they were earlier, still really good. And that's probably more associated with the band, this more that original band, this stuff. And then in between, this is a lot of coastal enhancement and was still decent mid-level dynamics in between the surface low pressure and the mid-level that band, that Frontogenesis band to the north. This shows that the surface low is still intensifying because we're still pumping moisture at a pretty good rate, even though it's not quite like we saw earlier in the day. Still pumping pretty good moisture and still getting pretty big time band. You can tell it's a little bit more coastal enhancement just based on it's like a big blob of moisture rather than a well-defined curvature band. And this was kind of the later that night. So this is about 5-6 hours later. So now we're starting to see it's still kind of getting pushed out, but you can see this band forming right here. That correlates, with these snowfall totals. Notice the band, that was that band. So that was just going to pivot there for a while. And also what we look for a lot of times too is this is a terrain area. So a lot of times it's called orographic lift, where some of the terrain combined with some vorticity moving through the system, just energy is a better, easier way to say it. But some of the terrain with these systems can help enhance some of the precipitation here, and that's when we can start to see, a lot of times we see an inland band setup that's just hard to predict. Part of it is, models struggle with that, and also we get orographic lift, which is what models tend to struggle on. But also at this, there were still pretty good mid-level dynamics that were being advertised. So this wasn't really caught out of the blue in terms, but it wasn't matching quite on the surface. A lot of times the surface P-type maps precipitation type maps, they don't always match up well with how the banding sets up. So that can be a little difficult sometimes to forecast. So a lot of times you can see people post snowfall total maps and precip maps, but they don't always aren't actually telling the picture of what the model is even actually showing, just because sometimes the precipitation maps aren't all that good. and they can't always grasp the whole picture of what's really happening. Then we play another loop. Maybe I don't. All right, this is about 6-7 hours later. At this point, notice how now it's getting pulled farther south and west. This is that banding, and this is, again, this is what allowed these places here along eastern PA. They sat in this banding for a while, and these were really good snowfall rates. They had good lift throughout the atmosphere. Omega was pretty supportive. It looked like, which we look for as snowfall growth. Snowfall growth is key. It's key with these systems. With every snowfall system, it means how good is your snowflake production. When you look at snowflakes, there's a difference. You know all the different kinds of snowflakes. That really does make a difference, believe it or not. So a lot of times those crystal, almost sleet pellet like snowflakes that can feel a little bit, that are really small, potentially a little bit hard even for the size of them. That can limit your snowfall rates and sometimes cut down your snowfall totals, which is not good if you want a lot of snowfall, obviously. So what we're looking for is we're looking big fat flakes. We don't want them to, ridiculously wet, because really wet flakes that can make it hard, that can start to compact the snow down and make it hard for snowfall production as well. Those snowfall rates can make it hard. So what we want to look for is a little bit of an in between of those big flat, big fat wet flakes, but also dry enough to the point where they're not compacting too much. So we look for what we call them dendrites. We look for dendrites. Those are snowflakes that are going to help those snowfall rates increase even more, and that means the lift throughout the atmosphere is really solid. It's hard. It's a little bit harder to explain without me showing you. And I will bring this up, through many snowstorms, because I'm trying to. It's hard with the reanalysis. I'm filling in pieces of what happened, and I don't have every piece of the puzzle that we would go through in an actual snowstorm. So, but we can still get a pretty good idea. Obviously, it's just I can't get every little piece. And with these streams, I like to get every little piece, because every little piece makes a puzzle. And if there's pieces missing to the puzzle, then you're not getting the complete picture. And I like to get the complete picture to the best I can with my understanding that I have. And at this point, you can still see here. This is probably a little bit, honestly. Where are we? It's February, so it's probably not a ton of lake effect, but there's some sort of enhancement that's going on here. A lot of these bands at this point, it's probably a little bit that band fading. No, even that's a little bit west of the band at that point. This is the same timing of the last radar loop too, but we're still getting a lot. It's a little blotchy, it's a little patchy. But still getting some pretty, notice here, even this pop up. This is probably a little bit of orographic lift. So remember when I showed you this GIF here, towards the end of this, can I pause it? Yes, I can pause it. There we go. So this is around, it's a little off. I want to pause it at the right time. Here we go. Even then, it's still like a couple hours later, which makes a difference. But notice the banding coming down this way, and that kind of matches up with what we're looking at on radar at this point. You see here, just like that. It adds up. Again, that's the model prediction, so it's not exactly what happened, but it's relatively close to get you the idea. And then a little bit later, this matches up a little bit better. Oh no, I thought I was going to sneeze for a second. But again, this was Philly starting to get into. So Philly, they probably mixed at some point. I forget exactly how it worked out for Philly, but Philly was able to get in a lot of this. I wouldn't say back in, but second half of the storm snow, and see a lot of these bands are working down at this point. Not quite at that angle, more like this, but that's what helped Philly. I think they got. I mean, what did they get? I mean, yeah, they got like a foot of snow. So it's amazing. The system so long. The system went on, and there's just so many different components to it. You can see here too. This is close to the same time, about an hour before. But a lot of these, I can match it up to show you with radar too. And notice here on nope. Pause it the right time. No, a little too late. I paused it. There we go. You can see this. Notice this mid-level vorticity right here. That's going to match up where we saw this banding. So this was around where it was, that mid-level vorticity. And then remember, we look for just to the north and to the west of it. And that's where we got this banding that going on. Being pushed down to the south at this point because we're at the end of the pivot process. Remember the pivot process? The band works out, we back the flow. Then we get to here, and the band starts to get to here, and then the band gets directly straight. It's kind of working out like this. And then probably it will, and then we start the storm movement, start to move out this way. I mean, the band doesn't move itself, but the storm movement works this way, and the band probably decays or decays with the storm movement, or just rots out because we've slowed down the storm so much. And if I play out the whole radar loop here, this is what we be able to put all the pieces together. This is the Central Long Island radar that they use for NWS Upton. Well, I mean, it's not just used by them. Anybody can use it, but you can just see how long this lasted. At this point, we have 700, 500 low working over, so we got dry air in here. But even in between that, still still pumping in moisture for a while. And now it's getting pulled out this way to the east towards the end. I mean, such a dynamic radar loop. Flow is starting to get back. That's our big band that put all that snowfall down. That band getting out into the interior. And now banding starting to work down this way. Storms kind of starting to pull out at this point. But as it pulls out, there's still so much energy left over that there's still moist, and there's still enough moisture that it's able to get pumped out. And just, I mean, for days, we saw snowfall with this system. That's that fire hose of moisture originally working to the system. I mean, just a fascinating radar loop, really. Same here. Just another radar loop as well. I think this is more of, this will get in this will get the whole picture and not just from one radar site. Right, now this band pivoting. Now this it's working down. Still back in the flow in now, just farther north. And then now the surface low is kind of it's bottom out. It's now no longer in strengthening, so we're no longer back in much flow here. And as these bands are pulling out now at this point, and that's pretty much the end of the radar loop. So this was a. I'm gonna go back to the. I mean, satellite too. You can get a look here. You can see what I'm talking about. Just a fire hose of moisture. It's not, it's not the prettiest look ever, but it's she did well. I mean, it's a beautiful for a big snowstorm, but it's a beautiful for a snowstorm, but for the beast's a beast. It's not the most typical because it is pretty broad. It is a bit broad, but that was part of what came with the system. There's satellite after, you can see all the snowfall. Oh, there we go. Looks like that zoomed it in. But yeah, such a dynamic system this was. Not dynamic in maybe as dynamic as you would think for these kind of snowfall totals at 500 and just the low pressure system, but the mid-level dynamics combining, with just a strong enough low pressure system. I think we got into like the upper 980s. It bottomed out at, so it wasn't it wasn't like a 975 or anything like that. But it was strong enough, to get a really good, and it was a deep enough trough base to get a lot of moisture to get pumped into the system, and with consistently good mid-level dynamics throughout the storm. This is what made it, one of the two biggest blizzards of the winter. I mean, and the other competition was a snowstorm that produced 4 feet of snow. So there's different ways you can get snow, and these two were completely different. The last storm, the storm earlier that winter was a excuse me, it was a big time, just a big time death ban. It was a little bit different. It was more than just a big time death ban, and just waves of moisture that were pumped down, and lot more meso banding. But yeah, since everyone kind of left, I think that can just about end it. Since this one will be a little bit shorter, it'll be easier for people to go back and rewatch, which is the good news. But I was, a little. I can't. I mean, I'm saying this that my schedule is different than others, so it allows me kind of to stay up later. But so I'm not gonna. Maybe people were expecting a bit earlier, but I mean, I've been consistently. I told the time of the stream as well when I was gonna start. It was right after Monday Night Football. That's when we started. But I guess a lot. They'll just people have to go back and rewatch it. But yeah, hopefully we can get more people into the next storm, and maybe we'll try to aim for a weekend. So less people have to get up either for school or for work, or exams, etc. And from there we can get more people, because a lot of people seem interested. I mean, I'm not just BSing here. I mean, I'll pull up Twitter here. Was it? No, this was. I mean, I ain't BSing. I mean, there's a lot of people that seemed interested. There's a lot of interaction on this tweet, but I guess maybe we started a little bit too late. So you can go back and watch it. They'll be able to go back and watch it. As long as if they go back and watch it, and they can go and get hopefully I didn't stream too late for them, because it's less about regardless, I'm going to enjoy what I see from the storm, and I know what I know what I see, and I can go back and enjoy it for myself. But I feel disappointed, but not because I like interacting with people in here, but just want just people to get what they want. I guess they wanted to see it, and we didn't get it as popping as I thought it was going to be, but that's okay. Again, we'll try to aim for maybe a weekend next time. It's always a learning experience. There isn't any impactful wet weather at this time, so gotta remember that as well. But all right, I'll see you until the next stream. Maybe we'll do another winter stream later this week, or the tropics could be kicking up. Remember, we gotta watch the Caribbean and the tropics, so that will be we'll have to watch for that maybe later this week or next week at some point. That should be interesting. So yeah, for the none of you that are in here, I hope you'll have a good night, and